The broadcast is now starting. All attendees are in listen-only mode.
Hi, good afternoon and welcome to today's webinar. My name is Lorenzo Bossi. I'm the Sales and Marketing Manager here at CompoSIDE, and joining me today is our Application Engineer, John Evans.
Hello everyone.
Today we'll talk about composite materials data, plies and laminates for design and FEA purposes. The webinar is scheduled to run for about 1 hour, including some time for question and answers at the end of the presentation. But should you have any questions, please feel free to post them at any point during this presentation in the questions panel, which is on the right-hand side of your screen. We are going to record this webinar and upload the record on YouTube, along with all our previous webinars and our over 70 video tutorials on the main features of CompoSIDE. But an email will notify you once the video and the presentation are available online. Our agenda for today will touch on a number of points about composite materials data and design for FEA requirements. We will start with just a brief introduction to CompoSIDE, just to highlight the challenges of working with the composite materials. We will then enter into the subject of the webinar, discussing the requirement for pre-processing of composite materials for design and FEA, followed by a live demonstration on the design of a typical panel for aviation, rail, or automotive requirements. We will finally allocate a few minutes to answer any questions you may have before concluding this session. So for a brief introduction to CompoSIDE, CompoSIDE actually means Composite Software Integrated Design Engineering, which is basically a fully integrated platform for the conception, design, and automated reporting of products and parts built with or without composite materials. The software was officially launched commercially in early 2015, following 5 years of research and development and software development. It had quite a good success within the industry, with over 100 registrations by the end of the first year, while nowadays we're closer to 250. And just to give you an idea of the scope of usage, we have more than 150,000 finite element analysis runs that have been made on the CompoSIDE servers to date. CompoSIDE features a number of integrated modules that cover the entire product development cycle, from the preliminary to the detailed design and analysis of parts and products, once again with an emphasis on composite materials, but not limited to composite materials. It's a web-based platform which is built around the fundamentals for multiple users and multiple projects, so that within CompoSIDE, your colleagues and different teams can collaborate together on the same project, while always working with the same data sources and the most updated values and designs. CompoSIDE also includes dedicated modules to the management of materials, plies, and laminates. This data is then used within beam modeling, 2D sectional drawings, and 3D design and FEA modules. Or alternatively, you can take this data out to third-party design and analysis software. Finally, there is an integrated reporting engines, which also features a bill of material generation and automatic reporting, which allows you to basically create manufacturing data such as the laminate tables at the click of a button. We'll provide further details and demonstrate some of those functionalities later on in the webinar, but for now we wanted to highlight the importance of the material data in this process. It is obviously something which stands at the beginning of any engineering work which is done with composites, and therefore is of primary importance that we have the choice and the ability to select the right materials. So working with composite materials and the importance of materials data. So when you're working with composites, the first step is generally the material selection. There are many base materials such as fibers, adhesive, resins, scores that you can choose from, and one could even say there are a few too many of them. But what is important is that you are making a decision on the performances and the cost of your end product at this very point when you select your materials, and those decisions can actually greatly affect our product costs. There is a secondary aspect to this, is also to consider the costs and the time required for material qualification. Depending on the industry in which you work in, that may be just a few thousand to hundreds of thousands of pounds or euros. And so you need to be in a position in which you decide or not whether you want to go forward with some testing of qualifications on new materials. The second step of the design is the engineering part of things, and particularly with a number of tools and different levels of complexity that are used at each of the different stages. Ideally, one could start from the basic concepts using classical laminate theory and some conceptual design tools, then move on to 3D modeling and FEA. What is important in terms of material data is that the further you go in the design process, the more complexity and details you have, the more data you need about your material in order to analyze their performances. The final step would be the manufacturing process. That could include either or both the materials or the part manufacturing itself. There are many processes available today to the composite industry, and each one of them affects the material properties and the costing in different ways. Each process would also have certain specifications in terms of the amount of material that are used and consumed or that are wasted throughout the production time. This is very much an iterative cycle, which basically requires us to work consistently from material selection, engineering design, and processes selection in order to get the best out of our product price and development cycles. Once again, the point here is to highlight the importance of the material selection and qualification processes at the very beginning of the design or product development process, and the impact that those can have throughout the entire development life cycle. So this being said, what options are available to us in order to source material data? Well, we can always go to material manufacturers. We can ask for specific data sheets about their materials. It's an exercise which is relatively low cost, so primarily just requiring our time and effort, but it's also something that primarily has given a limited amount of data which may be sufficient for an initial calculation, but we will quickly realize we need more detailed data in order to perform any detailed engineering or finite element analysis. Sometimes also those values are more of a best test scenario and are not really characteristic values of what can actually be the final product as if you were acquire various volumes of a given product. The second option we have is to acquire tested data. That would definitely give us more qualitative and quantitative data about a given product. Overall, it would also cost more in terms of the investment we are required to make at the beginning of the process. But there is a further limitation to that, is that we are only able to explore the options of materials that are given to us by the data that is actually present within the bulk data set that we acquire. And furthermore, those are generally data which are related to a single manufacturer, and hence if we start working with this data, we are again tied to that very same manufacturer. The third and most effective option is that we can actually run the test data ourselves. We can run a number of test campaigns, extract the characteristic data of the materials, but obviously here we start talking about tens of thousands of pounds if we want to just do a couple of static tests for 2 different materials. Once again, the materials can be a fiber type, a fabric type, a core, a resin, and every time we change one of those, we would have to remake the very same investment. So there are definitely a certain number of options that are available today for us to acquire data, but it's not something that, as you can see, can be done at a low cost, low upfront costs, and they would accompany us throughout the entire product design cycle, meaning all the data required to perform detailed product design and FEA analysis. And so the very question that we'd like to ask today and challenge the market to is whether do we really need to spend tens of thousands of pounds or euros before we actually start designing with composites, because the costs of material selection, sourcing and testing clearly outweigh the basic need and requirements of design engineering upfront of the project itself. So some of you, I guess most of you are familiar with the testing pyramid. We start from the basic coupon analysis, then we look at elements and the details until full-scale test. The higher we go in the pyramid, the higher complexity we have in our product, but we're also reducing the number of tests required. And now, speaking of testing, is not a single test that needs to be done, but is obviously a number of tests that will give us sufficient data in order to perform a statistical analysis to which we derive then, in this case of coupons, material characteristic values, two different industry, different partial safety factors, and then project design allowables are derived from these data sets. What we have done here in CompoSIDE in order to try to combine materials data into a centralized and usable database to evaluate designs without large upfront investment is to take coupons data from a given material but different manufacturers, combine them with the characteristic values, so it's post-processed data from number of tests performed throughout our projects, and then combine them with a typical manufacturing process that would affect not only the properties but also give us indicative values of usage and wastage of those materials if we were to go into production. And that hopefully would give us what is called materials data fit for design and FEA. This is data that basically is manufacturer independent, so I mentioned for most of the materials, I will explain the exception later on, but for most of the material we'll be talking about generic materials that can be, for example, a unidirectional 200 GSM, standard modulus carbon, epoxy and pre-preg that you can then source by any type of manufacturer in the industry. To each one of those, I mentioned we have associated a manufacturing process. So whether you're looking at hand layup, vacuum infusion, automation, there are certain characteristic values that are changed according to the material and the process select. And basically this data is able to perform an initial material selection when you start designing or evaluating the option and properties of a number of composite parts. The data is fully compiled in order to be fit for design and FEA, which means it's something you can use in your hand calculation, classical laminate theory, linear and non-linear analysis throughout without having to acquire any additional data in the middle of your process. And it's something which will ultimately allow you to explore the design space by giving you more choice in terms of the materials you can use without actually having high acquisition costs at the very upfront of the project. And what it means in terms of data is that we have a database which is called the CMDB add-on or CS material library, which starts with the inclusion of 1,250 plus materials, including a selection of fibers, resins, adhesives. I mentioned most of them are generic. So exemption is made for the cores, which are very much of a commercial product, and you can really source them generically. In addition to composites, there is also a selection of wood, plywoods, plastics, and metals that are ready to be used, particularly if you are making a comparison between two structures or would like to make a conversion from a metallic structure, for example, to a fully composite one. In addition to that, there are close to 900 plies, which are created by a combination of fiber type, fabric type, selected process, and resin. And you can also create your additional plies using the plygen feature, which is included into CompoSIDE. So effectively, this is giving you thousands of possible combinations that you can create yourself in order to explore further the various options you have in terms of material choice. So in terms of the key modules that will be looked at later on in the live demonstration, I mentioned CMDB. CMDB is the Composite Material Database, so it's a management system to allow you to manage all your materials and plies. It basically allows you to build your own material library by using some of the 60 materials we provide and adding your own as well. It allows you to create and evaluate new plies through micromechanics, or to create new material based on a reference material data. All the materials can be fitted in with all the properties for calculation, and you can perform material selection, analysis, comparison, normalization. To materials, but whenever you're working on a specific project, you are able to subset those materials to only the ones you are most interested in, and it's making it easy to work on your daily activities without being overwhelmed. The CMDB add-on is the independent module which contains the actual data about the 1,250 plus materials. So I mentioned earlier coarse fibers, adhesive, resins, woods, plywoods, plastic, metals, and close to 900 plies. Those are all manufacturing independent, providing characteristic values which have been sourced by a number of multiple sources, and those are all fully documented within the CompoSIDE wiki page, which is associated to every material entry. The data are picked for design and FEA and allows you to export to finite element analysis for materials, plies, and laminates to a range of products such as ANSYS, Nastran, or Systractor radius. But we also support API calls and basic export to Excel if then you want to post-process the data in a different way. I mentioned earlier the concept of material libraries. So as you can see here, there is what is defined as a My Company material. This is the library which is specific to your own company that all of your users can access. Whenever you work in a, you can then complement this library with the CS material library, so the CMDB add-on, which basically contains in excess of 1,250 materials. And the materials that you select for the active project are actually going to be closed within a single folder that you can then further subdivide in material selections in order to facilitate the material data management. With so much data, there are also a number of tools that are used to select the materials. This is simply a screenshot example of a number of combo plies, just sorted for tensile modulus versus density, but you can actually select any of the properties we have and refine the selection. This is primarily in order to help you narrow down your material search visually. Or you can alternatively use filters for the product type down to a specific range of properties so that you can effectively compare materials within a narrower range of densities or any other properties you are mostly interested in. Another module that will be demonstrated in the minutes to come is LaminaSpace, which is basically our laminate management tool based on extended classical laminate theory. It allows you to create an infinite number of laminate families composed by either base laminates or sublaminates, if you're familiar with the concept. And is based on what we define an extended classical laminate theory, which provides engineering constants, allowables, through thickness shear, sandwich stability, loads analysis, and recently added coefficients of thermal expansion. Within LaminaSpace, you're basically able to review and store all your laminates to use in a variety of projects. You have an automatic detailed report that can be run on any laminate and export to PDF in again the click of a button. And you can take this analysis further, creating shells directly from any laminate, export your laminate tables to Excel, or again export those same laminates to your FEA tool of choice. So finally, some of the few options in summary. We start with 60 generic materials in our CMDB. You can import additional materials and plies through Excel, or you can complement your library with the CMDB add-on. Those materials can then be stacked in laminates that you can then export to Nastra and OptiStruct, ANSYS, ACP, or call through API or export to Excel. Okay, so it's now time for the live demonstration, and I'll give it on to John.
Thanks, Lorenzo. Okay, so before we go into the live demonstration, I just want to go through a typical project workflow. So what is a good starting point for a project? We need the base materials and the geometry of our product. From there, we can pretty much define everything else. So typically, to understand what properties our composite materials have, we need to define the processing type, matrix material, and fiber type. But that's just for plies. So we can choose different types of cores from their materials, so balsa, PVC, honeycomb, plastic, the list goes on. So compared to the materials, you can see our geometry is fairly simple. To select our materials, we can use CMDB to filter out the materials within a certain range that we are trying to achieve, and we can compare them against each other. So this is before we've even made a laminate out of them. The next step for composites is to create a stack-up or a laminate of these materials. So for this, we have to move into the next module, which is lamina space, where we can easily define our laminate and fiber orientations. We can also define sublaminates for different areas of reinforcement or areas that are just single skin without core. So once we have the laminate defined, we then need to analyze it. In Design Workflow 1, we can do that within FE space, within CompoSIDE, or we can use analytical hand calculations by exporting our material data to Excel. Or there are several FEA tools out there on the market, which Lorenzo has mentioned, which you can use to analyze your composite components. We at CompoSIDE believe that accessibility across these platforms is very important. And this helps you integrate your other tools and help you save time and money, which is why we've developed the material and laminate export functionalities. This allows you to use CompoSIDE both as an analysis tool and a materials database. Okay, so this is the second workflow. This is the external tools. So we can import your existing materials data into CMDB, or use the CMDB add-on, create a laminate with extended CLT, and then link that in very neatly with your existing CAD and FEA tools. So before we jump into CompoSIDE, I just want to introduce the problem. So we have a lightweight panel. This is typical of an aerospace project. We have a basic laminate, which is carbon fiber and epoxy resin. It's probably going to be infused, but I'm not too sure about the core choice yet. So from previous experience, I know that to keep weight and cost down, I wanted to find patches around the cutout, as you can see there in the red. And I'm also going to add the edge capping in as beam elements just to stiffen this up during the analysis. Okay, so if we jump into CompoSIDE. So this is our environment. It's all web-based. You can see that I'm accessing this through my browser. And we have the modules laid out in the center of the environment. We're going to focus on CMDB today, lamina space, and FE space. So the first module is CMDB. You may have seen screenshots of this before. So in here I have my CompoSIDE material library, which is the CompoSIDE add-on. I have my company materials, which are anything that I've defined personally. and I have my project materials. So it's all defined neatly into different folders and categories. You can see that in my project materials I have a range of materials, most of them cores. Because I'm not sure on which core I'm going to use, I'm going to use a selection of cores and work out which ones I want. So in the bottom here you can see I have two selections. One is cores and one is plies. Now if you don't want to create a laminate and you just want to grab materials from CMDB, I can simply export these to ANSYS, Nastran, Obdestruct. But let's have a look at the properties. So if I go into the properties scatter plot, I can plot the density versus longitudinal shear modulus, for example, because this is very important to me. I want to know how stiff my core is. So this is going to give me a good idea on which core I'm going to use to help me get a very good panel stiffness while keeping the thickness and the weight down. So I've got a range of densities from 100 kilos to 115 kilos. And you can see that just by hovering over the densities, I can have a look at the properties. So I can see that my T10 core by 3A is very, very stiff and quite lightweight compared to its competitors. So I think we're going to create a stack up with this. And I also did the same with the plies. So I knew I had a carbon and epoxy ply, but I used the same process to determine whether it was going to be hand layout, infused, pre-preg, etc. Okay, so I have my materials defined. The next step is then to create a laminate. So for this, we jump into laminate space. And we can create a laminate in here. And let's call this panel laminates. And we can define the fiber type and the manufacturing type. So I know this is going to be infused. So this is going to take data from laminate space later on in the software to create reports, bill of materials, work out the wastage and usage factors for my product. So it's very easy to create a laminate in laminate space. All we have to do is at the top right, add plies, add cores, and reorder them if we want a certain stack up. So I'm going to bring in 4 plies of this unidirectional epoxy infused ply, and I'm bringing them all in at 0 degrees, so I can edit them later. So once they're in, if I uncompress my stack up, I can simply double click and change the orientation of my plies. You can do this for more than one ply at once. You don't have to do it one by one. Okay, so that's my inner skin sorted. I want now a core material. So let's bring in my T10. And I want, let's say 15 millimeters. I can bring this in and it's added to the bottom of the stack. Now as this is a symmetrical laminate, I can use the sequence type, so symmetric odd, to mirror the inside skin. So it's very easy to create very large laminates. And if I change anything up the top, it will automatically mirror down the bottom. Okay, so my laminate defined. I can save and close this. CompoSIDE, what it's doing now is it's generating all these engineering constants. It's working out the generic data, so the thickness, the weight, the density, and the cost if I put anything in. I can also generate allowable strains, allowable bending moments for different types of failure. So you can see that this data that I've created is very detailed and fit for FEA, as we call it. We can also analyze this laminate with loads. We can apply bending moments, thermal loads, in-plane, out-of-plane forces. So for some designs, this may be enough to generate an automatic load or apply bending moment. We can also use CompoSIDE to analyze a panel. So the panel that we saw earlier, I've already defined in FE space. which I brought in as a step file. You can also bring them in as a DXF. You can create your own geometry within CompoSIDE. So this is very good for creating grillages, panels, and you can see that I have a shell element mixed with my beam elements. So my edge capping is reinforced with a section, which is a 2D beam element. Now you may remember that I mentioned I wanted patches around the edge of my panel. So what I've used is I've used rules. I can also use different areas that have been defined within your CAD geometry to define this, which is typical of some other engineering softwares. But I have two parallel rules which defines the longitudinal width and the transverse width of my patch. And then I can apply this to a few plies in my laminate stack up. So in my stack up I have my basic panel, and in my stack I can see that I've already defined some rules, so you can see the outline of this ply and the fibre orientation. So it's very easy to get a very good preliminary pre-study analysis complete of your initial design. So if I just show you some results. So these are the basic deflection results which you get. You can also analyze the element results for your beam. You can analyze shell results, so strains, membrane and bending, or just membrane. You can analyze your internal forces, which you can then take back into laminar space and optimize your design for weight and cost. And also you can just generate a reserve factor, so you can see that without too much post-processing of your results, you can get a very good reserve factor plot for your panel. Okay, so that's one workflow. From here we can generate a bill of materials and a report which is automatically generated. Well, I don't think we'll go into that today, but we'll go into the second workflow, which is to import these plies and laminates into other engineering softwares. So if we jump back into CMDB, you can see that we can export all of these materials to Excel, Nastran, OptiStruct, ANSYS. These are just materials. You can export these in these formats, or you can use laminar space to create the stack up which we've created, and then export the laminate family including sublaminates and main laminates into your preferred form. So I've done this already. If I give you a quick example of the file that it generates, so for this example we've got a HyperWorks model which I've generated from this CompoSIDE model. CompoSIDE exports the materials, so I've got 2 materials in my stack up. I may have about 50 materials in another project, but this one's fairly basic, and you can see that it's brought in all the material data, including both laminates. So I've got my panel laminate and I've got my additional plies laminate, which is around the center of the cutout. Okay, so you can see that I've brought it in and I've applied it to my my panel, and you can see that I have my properties here. This is very quick to do and very easy. It links very well with HyperWorks. So if you're thinking about the amount of material data that it brought in, if we jump into hyperlaminate, for example, we can see that in my panel laminate, it has brought in my stack up, including the ply naming, the thickness, and the fiber orientation. So there's no data lost between these two transitions of softwares. Okay, so from then here we can analyze this further, depending on what you're trying to analyze, and yeah. Okay. So.
Thank you, John. So, in summary, what what we've seen is well, primarily two workflows that John has highlighted. The first one is if you're a company that is primarily looking to explore composite materials and don't really have FEA capabilities, there is what we call a design workflow within CompoSIDE that can allow you to quickly get started into the material generation, ply generation, laminates, and 2D, 3D design FEA, supporting also some of the CAD applications you may have, including DXF and step files. Bringing those into CompoSIDE would then allow you to create automatically all the reports and the related bill of materials. Now, that doesn't have to be a simple panel. That can be a much more complicated structure because we support multiple products. We can have, for example, an entire yacht with the primary structures and the holes that are imported within the platform and generating automatically the bill of material for all bulkheads, panels, beams that you may have inside. The second workflow is that for companies that are already using a CAD and already a linked solution with any of those three, or additionally in the future, FEA solvers such as ANSYS, Altair, or Nastran. And you basically have a number of options to connect the two systems. So one is using CompoSIDE as the material database management and laminate design tools, which allows you to export those. You can, on the other hand, also use it just as a material database. And for example, you will export MAT8 files for, well, MAT8 formats for software within the Altair suite or engineering data within the ANSYS Workbench platform, for example. And those two workflows work quite seamlessly within CompoSIDE and are applied by a number of clients today. So, in terms of summary for what we've seen single material data testing. And those are materials that can be used across a number of different industries by just applying your industrial partial safety factors and your design allowables. So in that case, when you think about it, what you're doing is that you're starting by selecting the materials, and it's only later on in the process that you're actually starting to validate those assumptions through actual testing. So effectively, what CompoSIDE can bring you is a number of tangible benefits, improved efficiency throughout the design process. That should allow you to quickly evaluate new materials, new laminates, new sections, and FEE models, whether inside CompoSIDE itself or using external tools. Is easily accessible and scalable, is a web-based application, so there is no installation required. Multiple users can collaborate on any project, which every user basically saving the data in a central platform. It means if you have a department that is dedicated to material science and they are bringing in new data, new properties regularly, you're then able to use that from offices in the other side of the world without having to ask for an Excel file, a CSV file, to then import that into your own FEA solver. But everything is basically centralized, and since it's web-based, you can go from 5 to 50 users, but in a single instant, basically. is something that can result in saving days of engineering resources. We found that using CompoSIDE, some of the project timeframes can be compressed by as much as 40% of the original time. Just imagine how long it would take to generate, for example, a bill of material for a complex structure. Those are weeks of engineering, not really engineering, but weeks of work that can basically be eliminated by just working within CompoSIDE and using some of the features we have. And hopefully that would result in an improved quality and consistency of your deliverables, automatically generating laminate tables, detailed section reports, detailed laminate reports that all follow a same standard format, which can either be based on a template we provide or a customization of the template by yourself. Is something will allow you to basically use a single data source for all those reports. And ultimately that would result in reduced project costs while also improving your own margins of operations within the different projects. So with CompoSIDE, there is also a level of support and training which is provided. Since the moment you start with a CompoSIDE trial, so we have a 30 days free trial available from the website. You'll be able to browse through, well, to use the software as if it is in the full version, but you'll only be able to browse through the additional material library that we provide. So you can only see the type of materials we have without access to the properties. But you can rely on the 60 plus we give you to start with in order to see what type of data we have available for you to work with. In order to support your application, we can, we provide dedicated video tutorial to most common operations. I mentioned earlier, those are all on YouTube or accessible from within CompoSIDE. We have a live chat where you can be connected immediately with someone from our support department, such as John. FAQs, a number of webinars for a different number of subjects. We run a few on marine, for example. We run a few others on optimization of lightweight structures. And those are all available on the CompoSIDE YouTube channel. Within the platform itself, you have access to a knowledge base, wiki pages. So I mentioned earlier, for example, any material you can add to the CMDB. You can actually attach qualification data. You can attach test results, test reports. So you make sure that all the data is linked to the single material data source, but also access technical documentation in terms of the formulations that are used within the software itself. Additionally, we offer dedicated training and engineering services that can be in the form of design training, can be in the form of sign-off services, for example, if you want to have a second look at a structure, down to independent, let's say, design services for a part or a product, given a product specification you may have. Okay, so we now have a few minutes for question and answers. I see there are a couple that already came in, so we'll start by answering those. But if you have any questions, please do not hesitate to post them into the questions panel, which is on the right-hand side of your screen within the GoToWebinar interface. Okay, so there is a first question that asks whether we provide the source of the materials data. That's well, let's put it in two ways. The source is documented whenever possible. So if you're looking at materials such as metals, that's obviously standard, so it's fairly easy. Other materials may be ISO certified, so that's fairly easy to document as well. In terms of the source of the data itself, such as raw test data, this is not something that we provide, but we only provide the post-processed data itself. There is another question in regards to whether we offer some academic users. Yes, we do have an option for academics. The best thing is that we'll get in touch with you after the webinar to let you know what the options are, whether you're doing whether it's for teaching or research purposes or PhD and so on. With web-based system, can users run CompoSIDE on their own server? Well, it is a good question. I think it really depends on the type of investment you're prepared to do, to be honest. A custom installation is something which is costly to maintain for us. The web version gives you the update. The regular updates gives you no headaches in terms of hardware maintenance. So there is an option there, but our preference is to be web-based. That will be much faster and simpler to manage. Okay, we have a couple of questions still coming, so don't hesitate to post them, because even if we don't take the time, we're going to get back to each one of you with the question itself. So there is another question: materials data in CMDB. How was it acquired? How many tests were done to define the properties? It has been acquired throughout a number of tests. I think each material has different acquisition sources, but I can say, well, there is not one answer to that would fit all the materials, other than the fact that they're not single sourced and they're not single tested. That's I think what is important, that the data is compiled from different sources and different tests itself. If there is a particular interest on a material, then I suggest we take that on a later stage, and we can provide further details in regards to the application.
So I've got another one. If I buy the CMDB add-on, is my data constantly updated?
Yes. Yes, so we're running constant updates. If you noticed earlier in the presentation, I kept the launch values, let's say, of 1250. But there's actually been an update, and you can see in our environment at the moment, with the new materials added, is closer to 1430 or something. So there are updates that are done regularly to the type of materials. If I can, for example, there is a recent study that was performed by one of the clients in, for example, application of T10 for wind industry. That's something you can search for, but I think the point here is that with the data provided in CompoSIDE, there was the ability to evaluate the performances on a material that was just released last year without having to source the material and run the tests. So basically, with an investment close to £5,000 in materials data, they saved over £20,000 from a number of tests that would have been otherwise run. So that's the idea that there is behind CompoSIDE, and the CMDB add-on is to give you new data as well, as soon as it comes out, as soon as it's possible to publish those, so that you're able to evaluate those new materials without having to source and test those yourself. There is another question, maybe difficult for me to answer, but we can have a look together, which asks which material models are supported for radius. Well, I'm not an expert in radius, but as far as I understand, and someone would hopefully correct me if I'm wrong, but basically you have, well, radius is not really in terms of the material data, is more of the solver, right? So in that case, what is important is that you basically have in CompoSIDE, we have options to export to, we can actually give you a thing, is easy. Exactly, so you export to OptiStructs in terms of the format, and you're basically able to select a number of properties, for example, well, number of options, from your material and properties IDs down to options to create P-shells or use strain-based allowables. You have a number of properties corrections, so you can be unfactored, for example, down to laminate orientations, failure theories, and a number of parameters I'm not familiar with, but they will be documented, or if you're a radius user, you're probably more familiar than me with those. But I think generally from what we've seen so far, and the reason we presented without a year is that we have a wide, well, we don't have any limitation in that term. Oh, good, interesting question is, does the database handle averaging and normalization from testing? There are two things here I think to consider. Is the database is not a post-processing tool for tested data, so it's not a tool at the moment. You know, it can always evolve in that direction, I think. So it's not used to post-process the data themselves, but it does allow you to evaluate new materials through a number of options. And I think the example is, for example, volume fractions and so on. So there are a number of ways in which you can actually create new materials using reference materials. You can calculate new properties based on a number of options. And well, I'm calling for your help, John. So when creating new materials. Okay, so there are basically options to recalculate the properties. I'm going to say dissociate stress from strains. You can manually configure some of the properties as well, and that goes for materials and plies as well. I think for this question, we probably ask a colleague to get back to you, and you can have a discussion around that. There was a follow-up on the previous question about uploading on their own servers due to potentially privileged models. This is understandable, and if you see at the very top of our connection system, we use encrypted and secured HTTPS SL level, which is similar to basically to internet banking. And the infrastructure is not actually hosted on our own servers, but that's AWS, so Amazon Web Services, which, as many of you may know, is actually supporting today more than, I think, 700 different governmental organizations, including defense and aerospace companies. So if there is a requirement on that side, I will be happy to provide more details, but that's a secured ISO certified facility for Europe, which is based in Ireland, actually. Okay, I think we're getting to the end of the time allocated today. I'll just get back. If you have further questions, please feel free to write at CompoSIDE info or support or sales at composide.com. We'll be happy to answer those questions. We do invite you to check out the 30 days free trial. It's something that is commitment free. All you need to do is go on the website, say start trial. You enter your mobile number, we'll send you a verification code, and basically that will deploy your own private instance site. The 30 days are supported by, I mentioned earlier, videos, live chat, support tickets, knowledge base, and our support engineers. So we'll be happy to support you in a number of benchmark cases that you would like to run. And as mentioned, no commitment, 30 days, absolutely free. We'll give you, and you will access to all the modules. The only limitation is the materials data, which you can only browse in terms of material names, but not look at the properties. That is aside the 60 original materials we provide to you, or generic materials we provide to you. So thank you very much for your time today. Hopefully you found it interesting, and we hope to see you soon on CompoSIDE.com. Thank you.
Thanks everyone.